Hello, higher algebra students, back here with lesson 4 of Unit 5, which is graphing inequalities and absolute values. We'll jump right into it here. So on the inequalities piece is very similar to just graphing an equation of a line. It's just about determining what part of the graph really are we referring to, because when we graph a line, it's just simply the line itself. But when we have inequalities, we're actually talking about a space really kind of above or below that line that we're interested in. So for instance, looking at this very first graph here, negative x minus 6 means that our intercept is at 6 below the 0. 4, 5, 6. So we're right there with the intercept. A negative 1 slope right here means we're going to go down 1, then over 1, down 1, then over 1, down 1, then over 1, and so on. Okay? So we've got our dots, but now we have to consider one more thing before we draw this line. If you look here, the inequality that we have between the y and the equation is a less than inequality. When we have a less than inequality, that means the line is not part of our work. And so what happens is if we have a less than or a greater than, we will actually draw our line as a dashed line to represent that that is not part of the true part of the statement, versus if we have less than or equal to or greater than or equal to, we draw this actually as a solid line, because that equal to means the line is part of our correct answer. So with this less than on this first equation, I'm going to draw this line, but with dashed marks. And now I have to look at, am I interested in, I want y to be less than my equation. So am I interested in the space above it, up here, or in the space below it, down here? And a couple ways you can think about this is, if we want y to be less, then that means we want y to be lower on the graph. And so it's the mindset is that it would be under the line. But another thing we could do is just put in the point 0, 0. Okay, so as long as 0, 0 isn't part of our line, we can actually test that. So let's put in, so we've got y is less than negative x minus 6. So I'm going to put in zeros everywhere here. So this would be 0 is less than negative 0 minus 6. Well, negative 0 is just 0. So the question is 0 less than 0 minus 6, which is negative 6? Okay, since this is false, okay, since 0 is not less than negative 6 right here, right, this would be inaccurate. That means that this dot right here at 0, 0 is not part of the area I'm going to shade for my inequality. So what I'm going to do here then is I'm actually going to shade beneath this line. Okay, and what that means is in all this area that I've shaded, the y value will be less than the negative x minus 6 line. Okay, so for instance, if I wanted to put in this point right here in the bottom corner, which would be negative 10, negative 10. Okay, if I put that into the equation, it would be negative 10 is less than negative 10 minus 6, right? So I've just taken this equation and put negative 10 in for the y and the x. Keep in mind the x was already a negative. That's why this is a negative 10. So negative 10 is less than negative is 10 minus 6. So is negative 10 less than 4? Yes, it is. So this is true, which is why we were able to shade that bottom part. Okay, so now let's look at the other line. The other line here, and this is where the system comes into play, is y is greater than 3x minus 2. So I'm going to go to negative 2 for my intercept, okay? And my slope here is 3, so I'm going to rise 3 and run 1. Okay, rise 3 and run 1. Rise 3 and run 1. So now what I want to do is actually figure out where this crosses my other red line as well. So I'm actually going to go down 3 and back 1. So we see right here, this dot that I'm coloring in right now is actually on the red line, but it will be part of this black line as well. And this black line is solid because it's greater than or equal to on this one. Okay, so now we need to figure out where on what side of this second line do we shade? So I'm going to, again, use the point 0, 0. And so with the point 0, 0, I'm putting in 0 for y, and then 0 for x. And that gives me 0 is greater than 3 times 0 is 0, so 0 minus 2. Is 0 greater than negative 2 or greater than or equal to negative 2? Yes, it is. So this is true, which means I will shade on the side that the 0, 0 is on, which means I will shade this direction now. And again, y being greater than, you can kind of see this would be on the top side of the line. If we were writing on, if this line were a slide, this is the side we'd be riding on, would be riding down the slide right there. And so that's that greater than or equal to suggests we're kind of on the top part of the slide, whereas the less than on the first one meant we were on the bottom part of the slide, which was that blue shaded region. So what I am going to do with this is I'm going to shade to the left of this line now. And you can see everything I've shaded so far really isn't that valuable because it doesn't include the blue. But now I'm getting down here into the blue, and I should have made my line a little longer there, which I'll do right now, so that it goes all the way down to the bottom. And you can see now my answer to this original question is what makes both of these true? And what makes both of these true is this space then right here. That's a little difficult to see. So let's see, I'll make it black here. Is this space that is colored both red and blue down in the corner. Okay, so that space, this black space, is the answer to this problem because it's now in the shaded region of both graphs. Okay, so this would be solving the system, which is under the red line, not including the red line because that's dashed, and then to the left of the black line, but including the black line because that's solid. Okay, so what we're seeing here is really we've got kind of the points that would be kind of an answer to both of these. So it would work for both of these, and those points are way down in the bottom left of the graph. And you can see we could find what exact points are on the black line and what exact points are on the red line in order to figure out what that border is. But right now it's just about the drawing itself. And so the drawing itself tells us that this here would be the answer of this first system of equations. So I'll make this next one a little cleaner so it's a little easier to see. And here it is. So we've got y is less than or equal to negative x plus 6. So what I'm going to do is try and make this as clean as I can. Here's the intercept, and it has a slope of negative 1, okay, negative 1x, right? And so going back the other way, it's 1, and I'm actually going to draw this line all the way to the edge of the coordinate grid. Okay, so I'm going to give myself these points all the way along. And again, this is now less than or equal to, and again, less than or equal to means it's a solid line. So I'm going to draw this line solid. And now that means that I have a solid line that I need to just verify what side I shade. And again, the y is less than or equal to, so be prepped to shade the under, but we'll just verify it with the point 0, 0 again. So I put in, so I have y is less than or equal to negative x plus 6. I'm going to put 0 in for y and 0 in for x. And again, negative 0 is just 0, so this is 0 plus 6. So is 0 less than or equal to 6? That is true. So I know that I will be shading under this line. So I'm just going to, actually I'll go sideways here, shade everywhere under that line. So I'm on the bottom half of the slide here, the underside of the slide, if you will. And of course, this shaded region goes on forever below that line, but we'll just keep it on the coordinate grid for now. Now, my second line, I have a little work to do because I don't have this solved for y yet. So I'm going to add the 3x to both sides. And when you do that, that now gives me y is greater than 3x plus 2, because the 3x is gone here. So y is greater than 3x plus 2. So I'm going to go to 2. I know it's a little tougher to see here now. And again, I want to make sure I figure out where it crosses the black line. Well, if I go up 3 over 1, that puts me right there. That's where it crosses the black line. So I'm going to go up 3 over 1. Now I'm going to go down 3 and back 1, down 3 and back 1, down 3 and back 1. And again, I know it's kind of difficult to see. But now I can draw this in. Uh-oh. Started to draw it solid. It shouldn't be solid. This needs to be dashed. So I'll dash the line. And again, the reason it needs to be dashed is because this is just greater than. Okay, if it's just greater than, then it's dashed. If it's greater than or equal to, then it's solid. And now I have to figure out what side I'm on. So it doesn't go through the point 0, 0, so I can check 0, 0 again. So I have y is greater than 3x plus 2. I'm going to put in 0 for y and 0 for x. And I get 0 plus 2. So is 0 greater than 2? No, it is not. That's false. So that means I'm not going to shade on the side of the line that 0, 0 is on. I will shade on the other side. And again, y is greater than here. So it would make sense that I'm on the top part of the slide and not the under part of the slide. So now I'm going to go off to the left here of my line. And you can see what my answer will be again. My answer is everywhere that I have colored blue and red. So the outline of my answer is this right here, really not including the red line, but including the black line. This is all my answer. And again, that's the area that I've shaded both. So any point that's in this region or further off to the left or up this way or down this way, okay, any point that's in that area would be an answer or a solution to this system of equations. So for instance, the point -8, 0, right there would work. -8, 8 would work. -8, -8 would work. Okay, -5, -1 would work. Anything over here. But over in this area, area 1, area 2, or area 3, it would not be a solution because area 1 is only a solution for the red graph. Area 2 is not a solution for either. And area 3 is only a solution for the black line with the blue shading there. So our solutions are in this area over here. All right, moving forward again. Okay, this one looks a little different because we just have an x is greater than or equal to -5 here. So we got to think about this. The x value being -5. So again, the x-axis is the horizontal axis. So I'm actually going to go back 5. Okay, but x needs to be greater than -5. So for instance, a 0 value for x would be greater than -5. So what I'm going to do is this is greater than or equal to. I am going to draw a vertical line. Again, this would be, the line I've just drawn is the line x equals -5, okay? But it's greater than or equal to -5, and I just know right now that since 0 is greater than -5, that I am going to shade this to the right. Okay, and I'll shade with the green this time to try and make it a little lighter. So all of this area to the right would work for this first graph, which is just that all this area, the x value for all of these points here in the green is greater than -5, right? X is 10 there, 9 there, 8 there, 7 there, and so on. Sorry, 10 here, 9 here, 8 here, and so on, okay? So now I'm going to solve this second equation for y. And this is a little more complicated because I subtract the 2x from both sides, and that gives me -y is greater than -2x plus 3. Well, I don't want -y, I want y, so I actually have to divide by -1, and what's done onto one side must be done onto the other side. But also, since I've divided by a negative, I actually have to switch the inequality. So this is now y, and instead of greater than, this is now less than, because I've divided by a negative number. And anytime you divide or multiply by a negative number, that switches the direction of the inequality. That goes back to our second unit of the year, or actually our first unit of the year. And so now -2 divided by -1, negative over a negative is a positive, so my slope is 2. And then +3 divided by -1, well, that's a -3. So my equation here is y is less than 2x minus 3. So I'm going to go to -3. I'm going to go up 2 over 1, up 2 over 1 for my slope of 2, up 2 over 1 over and over. And then clearly I haven't crossed the black line yet, so I'm going to go the other way now. Down 2, back 1, down 2, back 1, down 2, back 1, down 2, it's all the way down there is where it crosses. So I am going to just draw this line, and it's greater than here, or less than I should say now. So it's a dashed line because it doesn't have the equal to. Okay. Now, y has to be less than this. Okay. So first of all, I'm going to extend my black line so it crosses. Okay, that was an oversight there. I forgot that that red line went off the coordinate grid there for where they cross. So I'll even extend my green shaded area down below here, which was all the area to the right of the black line. Now I got to figure out what side of the red line am I actually going to be shading on. Okay, so the less than tells us we're going to be on the bottom part of the slide, but I'll just verify that by checking the point 0, 0. So I'm putting 0 in for y and 0 in for x, and that gives me 0 is less than 2 times 0 is 0, 0 minus 3. So is 0 less than -3? That's false, which means I won't be shading over the point 0, 0. So I will be shading then up to the right of this line. So by shading to the right of the line, what we're seeing is we got a big overlap here. But that overlap is going to stop right where they stop because we can't go to the left of that black line. Okay, so what that means now is really the whole right part of our coordinate plane, except for this area up here, is going to be an answer or a solution to this system of equations. So in other words, the point 10, 0 right here works, 10, 10 works, 10, -10 works, and so forth, would all be answers to this solution of equations, which again, to be an answer to a solution of equations just basically means that point fits both equations, the rule in both equations. Of course, this green area fit the rule for the first equation, but not for the second. And this area over on the left side over here doesn't work for either of these because it's already to the left of -5 for x. So our answer here would be that whole right area space. And again, that goes down till it crosses at, let's see, it would be 2 times at -13. So where this crosses here is the point -5, -13. And so we wouldn't go to the left of that point at all as we continue down that red line. So that would be the answer here for this one. Okay, now we're going to change it up a little bit, and we're going to look at absolute values. Okay, so the absolute value, first of all, the equation with an absolute value would look something like this right here. And when we look at this, we would look at A as being the slope. Okay, and for us, that will always be 1 for now. We won't put a value other than 1 out in front of the absolute value. The point HK will be our vertex. And by our vertex, we mean that most of these absolute value equations go something like this. And the vertex would be that point where it inflects like that, where it starts going, instead of going downhill, now it goes back uphill, or instead of going uphill, it goes back downhill if this were turned upside down. Okay, that would be the vertex. And again, it's x minus h. So if the h is a positive value, then it's going to stay minus. If it's a negative value, it'll be minus a negative, so it'll go to a plus. And so x minus 2 will actually have an x center at 2. X plus 2 would have an x center at -2, and so on. From the vertex, we move up and over one in each direction. So there's a -1 slope going into the vertex, as we see like right here, and a +1 slope going out of the vertex. So it forms that sort of V. And again, that's because we're going to use this A will always be 1 for now. That's why that works like that for us right now. Finally, we'll have to note the inequality to see if the line is solid or dotted, and then determine whether to shade inside of this V, so that would be like in this area here, or are we shading outside of the V or under it, which would be like this area here. So a good way to test about where we shade is to test the point 0, 0, provided that's not on the line. If it is on the line, then we just pick another point that would look easy to test. So let's do an action. So we've got y is less than, so the less than means we're going to use a dotted line. Okay, we know that. Now, using our rule, x plus 4, again, if you think about, and I'm just going to use an equality again, but we had x, oops, not x plus h, x minus h, and then plus k. So since this was a plus 4, that means it was x minus a -4 minus 3. So the vertex here would be at -4, -3. Okay? And what we mean by that is if we put a point here at -4, -3, okay? That point, if you were to put that into the equation, so if we put it into the equation, it would look like this. And at that point, we've got -3 on the left side. -4 plus 4 is 0. So that'd be the absolute value of 0 minus 3. Absolute value of 0 is just 0. So you can see it's where those two sides would be equal. Now, of course, -3 is not less than -3. It's obviously it's equal to -3. So that's part of the dashed line idea. Okay. Now, again, there was no value in front of the absolute value that was listed. So this is just a 1. So that means we're from that vertex, we're going -1 slope into the vertex and a +1 slope out of the vertex. But again, we're a dashed line because we have it as less than here. And now we have to figure out, are we shading above up here in area 1, or are we shading below down here in area 2? Well, the y is less than, so hopefully that's kind of your first giveaway that we're going to be under it, because down here is where the y is lower, okay? Up here is where the y is higher. But we can put the point 0, 0 in to test it. So let's do that right now. As I put 0, 0, again, my equation looks like this. We want 0, 0, in this case, to hopefully come up as true. So we'll put this in, 0 plus 4 minus 3. So is 0 less than 4 minus 3, since the absolute value of 4 is 4? Yes, of course, 0 is less than 1. So that is true. So the point 0, 0 right here should be in the shaded region, which it is. And so what we are doing here is we are going to shade below. And what this really is so we've shaded that area below because the y is less than. The line was dashed because it was less than and not less than or equal to. And we now have the solutions that would work for this inequality. So this is, again, back to the original question. This is where the y being less than the absolute value of x plus 4 minus 3 would actually work for this inequality. Everywhere above that v in the area that I have labeled as 1 would not work for this inequality. So if I put in the point, for instance, 0, 10, that would not work because 0 plus 4 is 4, 4 minus 1 is 3, and 3, of course, is not greater than 10. So moving forward, here's another one. Now we have a greater than or equal to, and we have x minus 2 plus 3. So what we're going to do here is, again, look at where our vertex would be. So with the equation, and again, I'll just write it as an equal statement. So my vertex, since it's a -2, that means that this would have to have been a positive for h. So my vertex will be at the point 2, 3. And so I'm going to go to 2, 3, put a dot. And again, I have no value in front of the absolute value, so my slope would just be 1. So I'm going to slope 1 up to the right from there, and 1 up to the left from there. And what you're seeing here is we have this intercept now of 5, or 3 plus 2 for the intercept. Now this gets to be solid. And the reason it's solid is because this is greater than or equal to. So now the y is greater than or equal to, so I think you'll find that we're going to want to shade up because we want a bigger y, not a smaller y. But we can always verify again with the point 0, 0. So I'm going to put 0 in. Is 0 greater than or equal to 0 minus 2 plus 3, with 0 minus 2 being an absolute value. So the absolute value of -2 plus 3, well, the absolute value of -2 is 2. And even if we hadn't taken the absolute value, this wouldn't have worked. But 0 is, of course, not greater than or equal to 5, so that is false, which means we would not shade the 0, 0 portion of the graph, and we would shade above up here. So this would be our answer. So again, solid line because it's greater than or equal to, above because we want the y to be greater than or equal to it. And the point 0, 0 did not work down here, so we don't want to shade the 0, 0 portion. And again, the vertex is at the point 2, 3 because it's set by the x minus 2 and then the plus 3. Okay. Here we have, in this case, this is really plus 0, right? So that helps us a little bit there. And when we look at this being a plus 1, that means that that has to be a negative because it's already, again, y equals x minus 8, not a parenthesis there. Okay. And so since it didn't show any plus there, that just means it would be a 0. And since this is a plus 1, that means it's technically x minus a -1. So that's why the center would be at, the vertex would be at the point -1, 0. Okay. So from -1, 0, again, there's no value in front. And so we would just go up and over 1 to the right, and then up and over 1 to the left. Now we have to look at, we've got a greater than, so that means our line will be dashed in both directions here. And with that dashed line then, we now just have to determine, are we going to shade above in area 1 or below in area 2? Well, the y is greater than, so again, you'll probably find that we're going to be above. I shouldn't say you probably will find, you will find, but we'll put the 0, 0 in anyways, just to show it. So we're going to put 0 in for y. And again, is that greater than 0 plus 1 as we put 0 in for x? So is 0 greater than 1? No, it is not. So that's false. So we would not shade the area that has the point 0, 0. We will shade the other area, which is the area above. But again, it has a dash line this time because it's just greater than. Okay, so the point 0, 0 did not work. So we aren't going to shade the portion of this graph that has the 0, 0, which would have been below the graph of the absolute value. Okay, very last one here. So here we've got a less than, so we got a dash line again. Less than means we're probably going to be shading down the bottom part. But again, now we don't have anything in the absolute value with the x. What does that mean? Well, that means the h was actually 0. So the vertex here as an x value is 0, and as a y value would just be -3. So we're going to go down 3 units to the point -3, 0, -3, I should say, because that h is 0 and the k, sorry, I guess I should have put this as k originally, is a -3 here. And from there, I'm going to go up one over one, up one over one, up one over one, up one over one, up one, back one, up one, back one, up one, back one, up one, back one. And I have to make my line dashed because it does not have an equals to with it. So I'm going to dash this line this direction and dash this line in this direction. And then again, I have to determine, am I going to shade area 1 up here or area 2 down here? And again, since the y is less than, you will find it's area 2, but we'll just verify by checking the point 0, 0. So if I put in this equation, if I put 0 in for y and 0 in for x, that hopefully should not work. And we get 0 is not less than 0 minus 3. 0 is not less than -3. That's false. So that means this area should not be shaded. So the shaded region, like we said from the beginning, y is less than, the shaded region should be under the graph. So we are going to shade all of this space down here. And that again would be with the dash line because it's not y is less than or equal to, it's just y is less than. And all of this space then that we've shaded would be solutions to this equation. In all of this area, the y is going to be less than the absolute value of x minus 3. Thank you for watching, and as always, if you have any questions, please ask.